Hello and welcome to Math with Mrs. Becker. Today in Algebra 2, we are going to look at the second half of section 5.7, where we will be graphing quadratic inequalities that this time only have one variable. So rather than looking at a full coordinate plane, we just go ahead and look at the number line. What we will be doing is first finding the x-intercepts, your zeros, graphing those. Those are going to be called our critical values. So let's just say I have a number line. You have two critical values. So let's say I have them here and here. What happens, your critical values separate your grid into three different regions. Here is a region, here is a region, here is a region. What you need to do is try a point from each region to see if you need to shade that area. Remember, you always want to shade what is true. So if this was my critical value, I would put a number from this side into the original. If it's true, I would shade to the left. If it's not, I wouldn't. Then you try a number in between your critical values. If it's true, you shade between. If it's false, you don't. Then you try a point to the right of your furthest right critical value. If you get a true statement, you shade to the right. If you get a false statement, you don't shade at all. Let's go ahead and do this, okay? So it says solve the inequality by using algebra. Okay, so again, what we need to do, you want to think of it as an equal sign first, so that way we can go ahead and find the zeros by factoring, complete the square, quadratic formula. So if this is my original equation, remember when you're doing any of these processes, you want to first get it set equal to 0 so you can figure out what method you want to use. If I add 3 over, I would have x squared minus 10x plus 21 equals 0. All I did is I took my minus 3, add it to the other side. I can factor this. If you have 3 terms without a number in the front, go ahead and check that multiply add method. See if you can think of 2 numbers that multiply to the last term and add to the middle. Here I could do negative 3 and negative 7. Negative times a negative is positive. 3 times 7 is 21. Negative 3 minus 7 more is negative 10. So I can factor this by saying x minus 7, x minus 3. But what I'm trying to do is find the zeros. So I can go ahead and graph those. So it's x minus 7 equals 0, x minus 3 equals 0. When you solve each equation, you will get a critical value. So here I would add 7, so x is a positive 7. Here I would add 3, so x is a positive 3. Now when you go ahead and graph them, we need to know if it's an open or a closed circle, so you look back at the original. These are going to be filled in circles. So I have a filled in circle at 7, and I have a filled in circle at 3. Now notice that what we have here, we have 3 different segments. So I need to know, is this true or false? So if I try 0, if I go 0 squared minus 10 times 0 plus 18 less than or equal to negative 3. And notice when I test, I go all the way back to the original problem. This would be 0, this would be 0. So my statement says 18 is less than or equal to negative 3. That's false, so I do not shade that region. Now we try a number in between 3 and 7. So let's go ahead and try 5. So if I have 5 squared minus 10 times 5 plus 18, we want to know, is that less than or equal to negative 3? So if I go ahead, 5 squared minus 10 times 5 plus 18. This is negative 7. So the statement says negative 7 is less than negative 3. That's true. So I shade in between the 2 critical points. Now I want to see if I shade all the way to the right. So I need to try a number bigger than 7. Let's try 8. So 8 squared minus 10 times 8 plus 18. Let's see if that's less than or equal to 3. I can go ahead and up arrow, just change all of my 5s to 8s. Good to go. And this is a 2. Is 2 less than or equal to negative 3? It is not. So we know that if we want this statement to be true, you can fill in 3 and 7 and any number in between. If you go beyond the 3 and the 7, you would end up with statements that were not true for that inequality. There is one sample question. Let's look at another one. Step 1, they want you to write it as a related equation. What that means is don't worry about the inequality until the very end. So we want to think of this as x squared minus 6x plus 10 is equal to 2. I want it set equal to 0 so I can see if I can factor or if maybe I need to complete the square or do the quadratic formula. If I minus 2, x squared minus 6x equals 8, plus 8 equals 0. I had plus 10. If I minus 2, that's a positive 8. 1, 2, 3 terms. Okay, so that's awesome. 3 terms, there's not a number in the front. I can multiply, add again. If you are good at factoring and recognizing that, it will take you less time. However, you need to remember that not everything is factorable, okay? But if you can factor it, it's going to help you out. 2 numbers that multiply to positive 8 and add to negative 6 is what we're looking at. Here, that's negative 4 and negative 2. Negative 4 times negative 2 is a positive 8. Negative 4 minus 2 more is a negative 6. So I can write this as x minus 4, x minus 2, because I'm trying to find my critical values. Now I take each piece separately, set it equal to 0. To solve for x, I would add 4. 0 plus 4 is 4. Here I would add 2. 0 plus 2 is 2. So my critical values, which I will graph as a filled-in circle, are located at 4 and 2. Now what I need to do is test an x value from each interval to see where I would shade. If I try to the left, I'm going to try 0. Go back to the original. 0 squared is 0. Minus 6 times 0 is 0. So when I test 0, I have 10 is greater than or equal to 2. Well, that's true. So that means the interval or the region where 0 is, that's going to be true. So I do shade it. So I'm shading to the left. Let's try a number in between 2 and 4. So I have to try 3. If I go ahead and I put 3 into the original, 3 squared minus 6 times 3 plus 10, I get 1. So the statement says 1 is greater than or equal to 2. Well, 1 is not greater than or equal to 2, so you don't shade there. Now I go ahead and try a number going to the right. Let's try 5. If I go ahead and just hit the up arrow, change my 3's to a 5, I get 5. Is 5 greater than or equal to 2? That is true, so I would shade going to the right. So if I want this inequality to be true, I need to pick numbers that are 2 or less, or 4 or greater than that. So basically, I cannot choose any number between 2 and 4. Let's look at another one. Step 1, write the related equation. So negative 2x squared plus 3x plus 7 is equal to 2. If I want it set equal to 0, I'm going to go ahead and minus 2. So negative 2x squared plus 3x plus 5 equals 0. This time I do have a number in the front. I'm going to go ahead and do the quadratic. A equals B equals C equals. A is the number in front of the square term. B is the number in front of x. C is the number at the end. If I'm calculating the discriminant, b squared minus 4 times a times c. When I go ahead and calculate that, 3 squared minus 4 times negative 2 times 5. I get 49. Nice. Okay, so x equals negative b. So it's going to be a negative 3 plus or minus the square root of 49 all over 2 times a. A is a negative 2. 2 times negative 2 is negative 4. Here's the cool thing with this. The square root of 49, that's 7. So when I go ahead and find my critical values, this ends up pretty darn nice. Negative 3 plus 7 is 4. 4 divided by negative 4 is negative 1. Negative 3 minus 7 is negative 10. If I take negative 10 and I divide it by negative 4, I get a positive 2.5. It is totally fine to end up with decimals. So I have, this time they are open circles. I have an open circle on negative 1, and I have an open circle in between 2 and 3. So now again, I need to try a test value in each region. So let's try negative 3. If I put a negative 3 in, negative 2 times negative 3 squared plus 3 times negative 3 plus 7. This side is negative 20. Is negative 20 less than 2? Absolutely. So we would shade to the left because negative 3 is to the left of this critical point. Now I have to try one in between. So let's try 0. If I put in a 0, this would cancel, this would cancel. All I have left is 7. Is 7 less than 2? Nope, so I do not shade in between them. Now I try a value that's bigger than 2.5. Well, I'm going to go ahead and try 3 because 3 is to the right, and then I can just go up here and just delete all of the negatives from the 3, and I get negative 2. Is negative 2 less than positive 2? Absolutely, so I would shade to the right. So again, you want to think of it as an equation. Either do the quadratic, factor, you could always complete the square, find your critical values. Graph them, make sure you know if your circles are open or closed. Your critical values, separate the graph into 3 regions. Test a number from each region. If it's false, you shade that region. If it is true, you shade that region. If it is false, you do not. Okay? Couple real life examples, and that is it for the day, you guys. The monthly profit, P, of a small business that sells bicycle helmets can be modeled by this equation right here. X represents the average selling price of a helmet. What range of selling prices will generate a monthly profit of at least $6,000? So you want to make $6,000 or more. Here is your profit, negative 8x squared plus 600x minus 4,200. This is your profit. You want this to be at least, so you want this to be greater than or equal to 6,000. Now I want to go ahead and set it equal to 0. Here's my original problem, okay? If I minus 6,000, negative 8x squared plus 600x minus 10,200 equals 0. See if I can divide everything by 8. I can. When you get big numbers like this, you do want to see if you can divide everything by a common term. And as long as you can divide all the way across, it actually just gets to go away. So here the negatives cancel, the 8's cancel, so I'd have x squared. 600 divided by negative 8 is negative 75. Negative divided by a negative is a positive. 10,200 divided by 8 is 1275. 0 divided by negative 8 is 0. Now this is a whole lot easier to look at. Now obviously looking at this, we could try to factor it. I don't know about you, but my mental math does not help me figure out two numbers that multiply to 1275 and add to a negative 75. So here, I'm going to go ahead and do the quadratic because I know that's the method that always works. X squared helps me to identify A. So A would be a 1. B, the number in front of X, negative 75. C, the number at the end is 1275. So this is B squared minus 4 times A times C. Let's go ahead and calculate it. So negative 75 squared minus 4 times 1 times 1275. This is 525. So X equals negative B. Negatives of a negative 75 is positive 75 plus or minus the square root of 525 all over 2 times A. A is a 1, 2 times 1 is 2. Well, if I take the square root of 525, notice it's not perfect. We're talking about prices. So when I go ahead and calculate the square root of 525, I'm going to round it like money. So $22.91. So I have 75 plus or minus $22.91 over 2. Here are my critical values, and in this case, it's a price. So 75 plus $22.91, it equals, divided by 2. Money, so this is 48.96. Now I go ahead, 75 minus 22.91, divided by 2. 26.05. So those are the two critical prices. So if you are the person who is in charge of selling these bicycle helmets and you want to make sure that you make your $6,000 or more, this is going to help you figure out how you should price your helmets. So if I'm going to go ahead and do my number line, let's go 0, 10, 20, 30, 40, 50. Looking at my original problem, this would be a filled-in circle at 48.96, so in front of 50. This would be a filled-in circle at 26.05. So now I need to see, okay, how should I price these bicycle helmets? If I try a 0, if I put in a 0, back up into the original, this would be 0, this would be 0. I would have negative 4,200 is greater than or equal to 6,000. Well, if negative 4,200 is greater than 6,000, we're in big trouble. That doesn't work. So what this tells me right now is you should have no prices in that bicycle helmet shop that are less than $2,605. If you're pricing things less than $2,605, you're not going to make enough money. Now let's go ahead and try a number in between. So let's try 30, okay? So negative 8 times 30 to the power of 2 plus 600 times 30 minus 4,200. When I try 30, this is 6,600. Is that greater than or equal to 6,000? Absolutely. So I go ahead and shade. So here, this is showing me that I should use prices that are in between 2,605 and 4,896. Now let's see, should we go higher? Like, hey, if we start increasing, let's try 50. What if we like mark all of our bicycle helmets so they're $50? Well, here, then I end up making 5,800. So what happened here, when you get over this price point, you're probably priced too high. This is not a true statement. So you should not price anything higher, because then what's going to happen? People are going to go into your store and be like, yo, look at their prices. And they're going to shop somewhere else. So you're not going to make as much money. So if this were your bicycle helmet shop, you would want to price all of your helmets in between those two prices in order to ensure that you make enough money to keep your business open. And that, you guys, is 5.7. I do have another example. However, it's exactly like this. So rather than have you sit here and watch a video, I'm going to let you start on the assignment. It is a book assignment today, 10 questions. So you'll go to page 370 and you'll go number 8 to 11. Jump ahead, 24 to 27, then check out number 52 and 61. Congratulations, you just finished 5.7. I'll talk to you soon.